Hey everybody, this is Larry. This is me going Q4 of the weekly contest for 2 Peaks in a Way. Hit the like button, hit the subscribe button, join me on Discord. Let me know what you think about this one. So this one is a relatively easier Q4, but I still made 2 silly mistakes. And both of them are actually, as far as I remember, well, okay, one of them was, well, okay. Both of them are kind of indexing errors, off by 1 errors. And the reason why they're both indexing errors is because one of them just had 2 indexing errors cancelled out, and I just kind of got the wrong answer. I got the right answer, but then it was wrong. But yeah, but I don't. The only observation that I think you have to make is that, well, okay, the 2 observation, right? So the thing that I misread is that you have to do it for the subarray so that it becomes. For example, here you just do 414, even though this 4 is clearly a peak, so it's 0, right? So that's one. The second is the more critical observation is that when you do an update, there are only 2 things that, or there are only certain things that can change, right? The current number, the current index can change its peak, and also the number to the left and the number to the right can change its peak. So basically the changes are very localized. And after you realize that, then you can do anything, right? Yeah. So there are a couple of, and then the other part of it is just being able to answer this in O of faster than O of n, because if it's O of n, it's probably too slow, and doing this in also fast enough time. Let's say log n. Because, well, if this is O of n, then that's also too slow, right? You need to reprocess some stuff. Yeah. And basically the idea now is just having the data structure that matches it. And yeah, we've been doing a lot of segment tree lately. So I imagine, I don't know if it's true, but I imagine a lot of people just put in segment tree, and it is true that you can do it that way. But the way that I did it is with binary index tree, which I have here. This is basically a template of mine. So yeah, so binary index tree. I'm not gonna go over this one or Fenwick tree. But if you want to Google it, you can Google it up. But basically, the way that I would think about it is that you have you have a thing that supports 2 operation. That's why it's called an ADT, an abstract data type, because you are able to use it in an abstract way. And an increase, and basically the 2 operations, increase just allow us to do, increase, I don't know, the value of I for whatever it is, by X, right? And you can do this in this gets done in log n time. And then total is give total of or sum, if you will, of whatever it is, a sub 0 plus a sub 1 plus a sub 2 plus ... plus a sub I, also in log n time. And in that way, this is a prefix sum. That's how I would like to think about it. Because, and it may be helpful later on. So okay, so the idea here then now is that we declare a binary index tree. The way that I did it is I made it 1 index, which I kind of forgot, to be honest, and that's how I got a wrong answer. You'll see me later like wondering what I'm doing, because I confused myself a lot during this one just because of my indexing choices. But yeah, but you can see that we don't care about the left and the right, and then here we just go, okay, if num sub I is a peak, which is greater than its neighbors, then we set it to 1, which is increasing it by 1, right? And so that's the pre-processing. And then now this is the queries. The queries, you have 2 types. One is t is equal to 1, which is the, getting the range thing. And the range thing, this is something that's very common in prefix sum, so it should hopefully look familiar. If not, then this is something that happens in a lot of prefix sum. So definitely work on your prefix sum problems. But basically the idea here is that, as we said, bit subtotal of y is going to be equal to the sum of a sub 0, which is rather, and a sub 0 could only be from 0 to 1, right? Right? Oops. ... plus a sub x plus a sub x plus 1 plus ... plus a sub y, right? Something like this. So this is total sub y. Maybe I'm off by 1 actually, but okay, right? And then bit of totals of x plus 1 is going to be also the same, say, almost, more or less. Right? So then now, the idea of subtracting them is so then now, by subtracting them, we get a of x plus 1, or sorry, a plus 2, plus dot dot dot, plus a sub y, right? So that's basic, and this is the sum that we want. Why do we have this funky indexing, right? Well, there are two things, and it'll make it a little bit clear. Is that one is that I use one indexing, so then now, in order to get from x to y inclusive, we want x plus 1, and then we want x minus 1, but because we want to include x, so it'll be x minus 1 to include x, right, in the subtraction, but then we add 1 for the one indexing, right? Okay. And then, but the other critical thing is that we only care about a subarray. Where's the subarray thing? The subarray rule, right? Meaning that we don't care about the beginning or the end. Like, another way to think about it is that if the beginning or the end is the peak, we just don't count it. And the way to not count it is just by, well, shrinking the range, right? So that means that you subtract 1 from the greater side, and you add 1 from the lesser side. So you shrink the range from the left and from the right. And I just have a max is equal to 0 just in case we have some funky things where x is equal to y, then this may be negative in some cases or something. So I just return it to 0. And that's pretty much the idea. And of course, I simplified it in the previous thing to, this is x plus 1 and this is y, right? That's how we got these things. And then the update is pretty straightforward as well. Kind of, maybe, if you believe the observations. So this is the set bit. But before we set, what I do is that and there may be cleaner ways to write this, but if there are cleaner ways to write this because I wrote it the unclean way once, because for some reason, I very rarely write it like this, but today I just feel a little bit sloppy. And I write it with not equal to 0, but of course, x minus 1 could be, I don't know, negative 1 for some reason, and then you can just run out of bounds. I was very sloppy, just Larry being dumb. But in any case, if they're bounds, this means that this is a possible peak. We check if it's a peak. And I guess actually this doesn't need to be a separate if statement. Before I was going to write this another way, but the idea here is that, okay, so this is before we update. If the previous before we update, we set everything to 0, right? So basically, this is the idea is that we want to set x minus 1 and x plus 1 to 0, and the way to do that is checking if it's a 1. If this is true, that means that previously it's a 1, so we add a negative 1 to make it 0. And then now, after we update, we just update it again. We set everything to, we check everything again, right? And that's basically what I have here, so that in future uses, everything will be good. As we said, everything's localized. And that's pretty much it. This is the core of the code. This is n log n time because each, as we said, increases log n time. For each query, this is 2 log n statements. This is 6 log n statements. So this is going to be q log n. So the total time is going to be O of n log n plus q log n. And of course, this is O of n space plus q space. N for binary index tree and q for the answer for the queries. And yeah, that's all I have for this one. And of course, you could use segment tree, and there are probably other data structures that you can use. You can probably also use square root decomposition, though maybe it times out because, I don't know, Leetcode is weird. But I don't know, I just like to drop it in. But yeah, this is the core of the code. This is the binary index tree code if you want to see it again. And that's all I have for this one. Let me know what you think. Thanks for watching. And yeah, you could watch me solve it live during the contest next. I made a couple of mistakes. One of the mistakes is that I didn't realize it has to be the subarray. And then the other mistake was that I just had some indexing issues. Unfortunately, and I had two wrong answers because the first time the indexing issues canceled it out, the sub array problem. So I fixed. Oh no. That was the second error. The first error was just this one. Yeah, I just kind of, I don't know. That's just a very sloppy mistake. Both of them are sloppy mistakes, but yeah. That's all I have for this. Let me know what you think. Thanks for watching. And you could watch me solve it live in the contest now. Sloppy, Larry. And people really got it. Wow, people are very fast today. Yeah, wow, I am just slow today. I mean, maybe that was it. Okay. 34 people. Okay. Wow. Peak. Number of count peaks. Change. And if this is set tree again. Okay, so then here, there's one peak. Pretty straightforward. I mean, yeah, okay. I'm trying to find my thing for my binary index tree. Yeah, this is a very easy problem. I guess the other one's kind of easy too, but I type okay, we need to do the thing first, right? Number peak, okay, so they just peak. I'm trying to find where there's 0 indexed to 1 indexed. He cannot be 0, Larry. What are you doing? I'm just sloppy today. The ideas are okay. Oh yeah, I need to check index. I knew that, but I'm still sloppy. How? Tell me how? Oh, it has to be strictly greater than. Okay, that's easy to fix. Misunderstood. And all sloppy. Still wrong. Oh, this is not I anymore. Okay, this is right. That's YOLO. Where? How am I so bad? I don't get it. Why am I just lazy on this one? I don't know why I wrote it that way. I usually don't. Today it's just... They don't even tell you what the answer is supposed to be. I think it's supposed to be 0, 0 anyway. I've been just way I don't know what's going on with my today. Maybe I should have used the sig tree. It is sig treeable. Okay, 7, 10, 7, 1, 2, and what is 1 again? Query 1 is counting, right? Am I misunderstanding this problem? Oh, I think I'm misunderstanding this problem. Because this is a stupid problem, actually. Okay, but like peaks in the sub-array doesn't, I don't know. Okay, fine. We could handle that, but right, but then it's just did I not understand this one? 0, 2, so 2, change 6, 10, 7, 0, 2. Zero, 2, this is 1, so that's why. How am I handling this so poorly? This is still -1. I think I just was wrong before, maybe. Nope. I do a +1, but then I don't do a +1 here. I think that's where I also messed up. So +1 and then +1, and then now we want a -1. So it should be this. This is very sloppy, but this is also still wrong. Maybe I just don't have the brain power for Leetcode anymore. 1, 2 is... Oh, 2, 2. Maybe I just misunderstand. Wait, what is going on? 2, 2. Why do I have 0? 2, 2. This would be 2. This would be 1. I think I'm just misunderstanding the misunderstanding. I think this is right. Maybe. No, then this is... well, lucky I didn't submit because I was about to. This is wrong for this one. Why? Because we have this thing, and then now we want 2 to 4. 0, 1, 2, 3, 4. No, 2 is set. Set index 2 to 4, which it already is, and then 0 and 2. Is 4 not a peak? I don't think I understand this problem that much, maybe. Oh, it is just a subarray. Okay. So then that means that... Can you just subtract this from this and then make this also bigger? But then this is how... Okay, so now this is right. I am just really bad at things, maybe. Let me double check again. Alright, YOLO. I'm just like really bad today. I don't know. I mean, a lot of sloppy mistakes on the indexing. And I think I just misunderstood what this problem meant. A couple of times. Just sloppy. Thanks for watching. Hit the like button, hit the subscribe button, join me on Discord. Let me know what you think about these problems, my explanations, the contest, everything in between. Stay good, stay healthy, to good mental health. I'll see y'all later and take care. Bye bye.